Well, hello friends, welcome back to Browser Hacking. Today we are going to work on the canvas stuff again, and we're going to bring up image data support. So we should probably start with finding some interesting demo for that. So let's see, let me use Google to bing this instead. Alright, well that's boring. Come on now. Canvas image data demo. And I guess the first one. That's an interesting pattern. So basically image data is just a way to get raw pixel access to a canvas. And you can get raw pixels of the canvas itself, but you can also create separate image data objects that can be manipulated on a pixel basis, and you can like tweak the individual RGBA values. So here is some example thing, and oh, very cool, it's animated. Alright, so this we definitely want to make this work. That would be very cool. So this is the code that we have to support. So let's just grab the document and put that into our little thingy here. So where do we put this? Oh, we'll just make a little thing for it, a little directory. Okay, and pixels example.js is this guy right here. Okay, so today we're not writing the example code ourselves, but rather we are borrowing it from the web. Okay, so we want this to run in the Serenity browser. So let's look at what they do here. So it just sets up an onload callback, and then they grab a canvas context for the canvas, and then they create a separate image data object, and then they loop over the width and the height, and then they set the individual RGB and A values. So alpha is always 255, which means that like it's always solid. And this looks pretty straightforward. So let's just support that. Here is put image data. This is how they actually draw the image into the canvas. So on our side, we're basically going to create a graphics bitmap and store that in some kind of image data object that we allow you to create and also get from the canvas. So we'll start by making the image data object, I think. So that will go in the DOM directory, image data, and then we'll need some bindings for it. So image data wrapper, and maybe that's it, actually. Maybe we can get away with nothing more. So let's see. Wait. Alphabet order is difficult. Image data.o. Alright. Mike. So image data. Oh, can't see the bottom of the screen. I got this little box there. Image data. Okay. So what is one of these things? We should look that up. But it's basically a ref counted wrappable thing, I think. It does not have events as far as I know. And oh, we have to put this in the namespace web. Here we go. And there we are. Great start. Okay, and internally we're going to have a ref footer to a bitmap. And actually, in fact, we'll have a non-null ref footer to a bitmap, because there's no such thing as an invalid image data object. Oops, bitmap like that. All right, and then I guess, how do you construct one of these guys? So we'll have to look this up. From a given uint8 clamped array. Okay, let's see how they were created in the example code. So he was doing context create image data. Okay, so that's the 2D context create image data. Creates a new blank image data with the specified dimensions. All of the pixels in the new object are transparent black. So that's easy for us, because since we're using 32-bit RGBA, that just means that all the values are 0, which is the case in all new bitmaps anyway. So we don't have to do anything for that. And the specified dimensions. Okay, so we'll just say that you have to pass it a size. Maybe you pass it this way, width, height. Okay, and then we'll put these things out of line, I think, just at least for now. We'll add an accessor for this, so yeah, that's fine. All right. So let's tell it a little bit more about this guy. So DOM image data, namespace web class image. No, what am I doing? Image data. Width and height. Okay, so actually, bitmap allocation can fail if you pass in some like obscenely large size. So we should probably, we shouldn't have a constructor that allocates, but instead we'll allocate in the helper, and then we allow the helper to fail. Create with size. We'll do it that way, and then the constructor will just take a pointer to a ready-made graphics bitmap instead, because then the constructor doesn't have to worry about that. That's better. I don't like having constructors that can fail to do something. Like, that's such a nasty place to be in with C++, especially when you're working without exceptions. And I never use exceptions because I don't like what they do to the model of program I have in my head. So, but because of that, some things are a little bit harder, but a lot of things are a lot easier. But this is one of those things, like, you can't fail nicely in a constructor. Anyway, so, let's put the destructor out of line also. Image data. Great. And then we'll make the helper, so image data, create with size. This will need, oh wait, we already included that. I guess we could probably avoid that. Just use forward declarations, that's fine. Okay. Graphics, bitmap, create. Graphics, bitmap format, RGBA 32. Size, width, height. Alright, so if this fails, if no bitmap, return null putter. Otherwise, return adopt a new image data with the bitmap inside of it, and we should be good. Oh wait, no, hold on. We're not good because it's a ref putter. So we'll release it as a non-null putter. So this is a, so here, this gives us a ref putter, right? Because it can fail. So that's what we check here. But after this point, we know that it's not null. So since ImageData takes a non-null ref putter argument, then we have to actually pass it in non-null ref putter. And the way that you can turn a ref putter into a non-null ref putter is you call ref putter release non-null, which takes whatever is inside the ref putter and asserts that it's not null, and then it hands you a non-null ref putter, wrapping whatever was inside this ref putter. But it's also removing it from the ref putter itself. So the ref putter, it's basically like you're moving out of it, right? So you move out of it while making it a non-null. Anyway, so that's good. And then let's just add those helpers, or the getters, I mean, width and height. Return and bitmap width. Return m bitmap height. All right. I think that's essentially what we need to expose on this class. Although this guy actually could be an amp because star implies that it would ever be null, but it's not ever going to be null. Okay, this MDN is so bright. So then we need to write a wrapper class for it so that we can expose it to JavaScript. Let's see if we can do this by hand, or let's not do that by hand. Let's just copy an existing wrapper. Event wrapper maybe. It's a boring class. So ImageData wrapper. ImageData. Clickety clack. All right. So we didn't write it by hand, but that's okay. And then let's add ImageData to the forward declarations, and let's put that in alphabetical order. And I think this will be pretty straightforward. But let's look at event wrapper CPP and go to ImageData wrapper CPP. So wrapping one of these guys is easy because it doesn't have any subclasses. So event is a little special because event can have subclasses. That's why we have to wrap it carefully. But in our case, wrapping is very simple because an image data is always just an image data. There's no such thing as like an awesome image data. They're awesome by default. Okay. And then we should tell the engine that the wrapper type for this class is bindings image data wrapper. And then we should also add that to here. Trying to be a very good boy about forward declarations here, because this thing keeps growing and build times are already an issue. Okay, so this guy should just be called impl. All right. Yeah, we're not going to make a separate prototype class for this now, or a constructor. We'll use the Canvas context 2D create image data to construct for now, but then later on we should go and add like constructors and prototypes to everything in the DOM. It's just that I'm kind of deferring that until we start generating this code because it's going to be really repetitive. So what do we want to add to this wrapper? We want to add a native function. Or wait, do we want to add a native function? I guess we wanted some native properties. These are the properties: data, height, and width. Native property width. So that will be a width getter. And there will be no setter. So let me just do that way. And for the height, static JS value width getter, something like that, I think. And then the data thing, it's gonna have to give us one of these objects. So this is an object we don't support yet, but we'll have to do it. And we could just give you out a regular array to be lazy, but maybe we'll do that today. But this one is actually supposed to have like the special behavior that it's like a byte array, so you can't have any other values than between 0 and 255. If we hand out an array, you can do whatever you want to it. But we might do that today just for simplicity. Data getter. But even if we give you an array, it still has to be a wrapper around the bitmap. So we have to make a custom thing anyway, no matter what. So, okay, what's wrong with this? Oh, we don't have act function. All right. So data. Okay, so then we have to define that uint8 clamped array anyway. This seems extremely similar to typed array. How's it different? Typed array. It inherits from typed array. If you specified a value that's out of the range, 0 or 255 will be set instead. So it's like saturating them? Right, yeah, because it's a clamping array. So I guess that's the difference between a regular typed array and uint8 clamped array. That this guy will actually saturate to 0 if you try to go negative, and 255 is if you try to go above. So this is a little bit unusual behavior. So I guess we'll make a custom class for it then. Is it part of JavaScript? I guess so. So let's put it in libjs. Libjs. I guess we can start with the regular array class. So uint8 clamped array. Very awkward name. But it is what it is. So yes, runtime. There we go. Okay, so this guy, oh, that's not what I want to do. So length getter and length setter. Let's not think too much about how this object should behave in the end. For the actual length, oh, that's awkward. So if you want the number of elements, you have to look at the prototype. Because that's what, static length property. So is that on the constructor? I am confused. What does that even mean? That's 3, okay. And then if we make one of these guys, 300, then we get that. Okay, so that's fine. Let's okay, I don't want to deal with the prototype part of it right now, so we're we're just going to pretend that there's no such thing as the static property on the constructor, and we're just going to put a length directly on the clamped array. And then we can fix that in subsequent work. So do that. And we'll have no setter. And if this object class name is not uint a clamped array, okay, and then string. Hey, what's even going on here? Oh, I was looking at this exclamation here and thinking, like, who wrote it this way? But I just wrote it this way like 30 seconds ago. So what we really want to do is just this. Okay. And I think then we have our thing. Now we just need to, because it's just going to act like an array. It doesn't matter so much. But it needs to have one of these guys. Wait. So we want a wrapper object, essentially. So we want this guy to point to the bitmap. To point to the bitmap. And then, this will be a little bit strange, but maybe, or we can also create the bitmap as a wrapper around this. That might actually be easier. Yeah, let's do it that way, because that simplifies this thing, because then this guy can own his stuff, and then we don't have to have like a special path where like sometimes a bitmap owns the data underneath a clamped array, and sometimes the clamped array owns it. So we'll just put data storage here, and I guess we will just malloc it. That's the easiest. So data fancy 32 length. Okay, and this guy is not going to return elements size, but rather it's going to return m length. And then this guy will do that. That's fine. And then we have to have a custom implementation of the like indexed lookup, right? So like bracket operator needs to go into a custom implementation of getOwn property on this thing. So that will be something to invent, but we'll get there in a moment. Okay, so then we're good with that. So how do we do that? So object, we're inheriting from object. An object currently, I think, lets you override getOwn property. No, it's not virtual. Okay. Well, we could make it virtual. Oh, excuse me. Let's make it virtual. And then here I will say getOwn property override. Yeah, that's good. We'll start with getOwn property. Oh, and we'll need putOwn property obviously as well. So these used to be virtual not too long ago, and then I made them non-virtual. Now we're putting them back again. But it's okay. It's okay. Do we have anything virtual here? Yes, we do. Lots of stuff. Okay, so we need to implement these two guys. And then when we create one of these, we also need to say how big it should be. So I think we'll pass it as a length, like that. Okay. We're just working this out as we go here. I think we'll assert that the M length is positive. Otherwise, we shouldn't let you do this. So if length is less than 0, I don't know what the correct thing to do here is, but let's just do this, or let's even just assert for now. Okay. And then in the constructor here, we will mallocate something. So ImageData is malloc mlength. Okay. Free ImageData. Assert ImageData. And let's clean up after ourselves because why not? That's really not tidy. Let's use delete. Still doesn't look very tidy, but it looks a little bit better. Okay. Okay, then we need those custom get own property, get own property, put own property, clickety clack. So we know that these are going to be numeric, but oh wait, hold on. Put by index. We know that if you're doing a put by index, can we override only that? So the engine currently detects if you're putting a numeric index property, and then it bypasses the regular put on property stuff and goes directly to put by index. But put by index really needs to call like an overridable put by index. But we could actually do that here as well. And then, yeah, maybe we should have a virtual. Maybe we should make this virtual. Why don't we make this virtual? And then we don't have to care about the other own property stuff. Okay, so we are rethinking this on the fly. We'll probably have to virtualize own properties eventually anyway, but maybe now we can get away with only doing indexed, numeric indexed ones. Okay, so trying this again. Get rid of these guys. And get by index. Okay, so this could work. Okay, back to the drawing board. Not really, the drawing room. Okie dokes. So, finally, now we can do the thing that we wanted to do and say assert that property index is greater than or equal to 0. Assert property index is less than mlength. We need to do something nicer eventually for this, but right now we're just going to assert, because I'm not sure exactly what the correct behavior is if you go outside of the indexable area. Like, did we just create an own property with that index, or what happens? This is how we're going to do it now. So m data is value to I32. And then I guess, do we have clamp? Yes, we do. Clamp value to minimum 1, minimum 0, max to 55. Oh, and we have to put some index. Okay, that's pretty cool. And then here we can just return it. So return m data at property index wrapped in a value. We'll cast it to I32 just to make sure. Just to make sure that we know what we're doing here. Okay. That looks pretty okay-ish, actually. It's a lot simpler than what I thought would happen. So we have this, and then now we have to go back to the image data stuff. Because now we're not going to have a bitmap here anymore. We're going to have a uint8 clamped array, essentially. So I think we'll put that in a heap handle. So this will allow us to hold on from C++ context. We can still hold on to a garbage collected object if we put it in a handle, because the handle will protect it from the garbage collector. So data, and these guys are going to have to be a little bit different, or actually no, they don't have to be different. We can create a bitmap and keep it around. It's just that it will be a wrapper around the clamped array. So JS forward. This should probably be one of the native built-ins, but we are just gonna. Dear gosh, what am I doing? We're just going to do it this way for now. So that's forward declared and nice. And then we have to create a wrapper. Create a wrapper. So if width or height turnover. I refuse to be part of this thing that you're doing. Oh, we have to provide the pitch. So I guess that's the width times the size of an RGBA 32. No? What's that thing called? Well, we can just call it a U32, whatever. And finally, we need a pointer to the pixel data. So how do we do that? lib.js, runtime, uint clamped array. We need to expose the internal data here. So let's see, we're gonna have to do some overflow checking, because otherwise Itamar is gonna come here and overflow the buffers again, like he did a while ago. So what am I looking for? Act checked. Checked. Checked int. Checked int. We'll say checked int size. Or maybe we should just have a limit here. We don't even have to do overflow checking if we just put a hard limit. So we'll say if width is greater than or equal greater than 16, yeah. So you don't get any bigger than that. No, you don't even have to get fancy. And then we need that thing, right? Uint clamped array. U8 data. Here is your raw access, dude. Static member function. Oh, mdata, right. So data is uint clamped array create. Shit, we need to know the global object. Well, I guess we're not going to be able to create one of these if we don't have a global object reference. So this is kind of like a little on the fence between web and JavaScript here. It's not super clear where we are context-wise. But that's okay. And then if data fails, we'll do that. And then if it doesn't fail, then we have it here. We just have to cast it to a U32. And then we have to give this guy the data. Maybe we... I was thinking we could store this in a handle right away. Or, wait, how do we do this? Data handle is JS make handle data. Yeah. And then we will give this handle to the image data. That's pretty okay. So just have to update the constructor here. Okay. Great. Okay, so in theory that will work. I'm sure I'm forgetting something, but let's go to the image data wrapper and make sure that we vend these things correctly. So I want one of those impl from helpers. Image data wrapper. So just making a helper here is to extract based on this object in JavaScript, just to find the image data whenever we're called here to do something on his behalf. Okay. And then we can start writing out those getters. So static JS value, image data wrapper, lang width getter, right? Auto impl is impl from interpreter. If no impl, then return emptiness. Otherwise, return impl width as a JS value. Okay, that's great. And then same thing with the height getter. That one is very, very similar, but the data getter is going to be a little bit different because he has to hand out the data. So we have that in JS handle, so we'll just let you access it as a JS unit clamped array data. There we go. This is looking pretty okay. So then we just need that Canvas API for create image data. That would be in Canvas 2D wrapper. Put native function create image data. I think it has 2 arguments. And also, what was it? Put image data, right? Let's see what this guy was using here. So we have create image data, and then accessing the data on the image data like this. This is what we're enabling with the uint8 clamped array. And then we have put image data to draw it onto the canvas. So that's these are the 2 remaining parts: create image data and put image data. Okay. And we'll be starting like this in both cases, and then all we have to do is just say impl create image data. Oh wait, hold on, we have to make an image data object first. This API does not exist yet, that's fine. So we needed to pass the global object that we're working with. And the width and the height. Argument 1 to I32. Okay. So now we have create an image data, and then we can wrap image data. Okay, I think that's going to be okay. We just need a bunch of includes here, so image data wrapper and image data. That's fine. And then put image data is kind of the same. Should probably take these out and call them like width. And height. Makes this a little bit more readable. Okay, and then same thing down here, except it's x and y instead. So x and y. And then all we have to do now is say impl put image data at. Oh wait, hold on. Put image data probably has the image data as an argument, right? So image data is the 0th argument. Image data object is interpreter argument 0 to object. Or actually, no, we'll do this. We'll to object him. And then we'll say if no image data object, return empty, because then we through. And I guess we have to pass the heap here. Class name is not image data wrapper. This stuff needs to become better somehow. It's so gross that we have to compare against a class name. string. But if this happens, we have to throw, so turn interpreter, throw exception, JS type error, put image data called with non-image data. I don't know, something like that, just so we can see what's happening. And then otherwise, we know it's an image data, so image data is static cast to image data wrapper, image data object, indirection requires pointer operand. Why? The web image data is invalid. Of course. Okay. Now we just need to implement those two functions in C++ and we'll be good. So Canvas rendering context 2D needs a ref putter to image data that takes a JS global object and a width and height. And it also needs a void put image data that takes an image data, really a const one because it's not going to modify it. And likewise, create image data is not going to modify the canvas, so we can make that const. It'll merely create a new object compatible with the canvas, but it's not going to mutate the canvas itself. So ref putter to image data, create image data, canvas rendering context 2D. Okay, and then let's name this guy. So here we'll need the image data stuff. Okay, and then I think we can just do like return image data, create with size, global object, width, and height. Really straightforward, just forward the call to image data directly. And then here, this is more like a traditional paint op, so first we check if we can get a painter to draw into the canvas. Or actually, first thing we should do is check if width or height. And I realize now that we shouldn't allow 0 width or 0 height either. Then just do nothing, okay. And put image data has X and Y, not width and height. So it's okay for them to be negative, that's fine. You can paint at a negative offset. In fact, these should probably be floats now that I think about it. Because you can draw an image data at a float coordinate if you like. We're not going to stop you. We're not going to let you make image data with like float size because we can't do that, but we can certainly let you blit the image data at an arbitrary floating point offset to double. It's the closest we have in JavaScript land, so we'll stash that in a float, and we'll even say auto. Look at us. Yeah, that's pretty good. So then we just need to do image painter. Painter. Blit at a graphics point X, Y. Image data dot bitmap. The source rect is the image data bitmap rect. The opacity is 1. Okay. So we've written most of all of the code now, I think, but we have some stuff to clean up that we didn't do right. So we have a static cast mistake in ImageData.h, line 25, which is the getter here. The cell is doing a static cast of a cell. So because we don't see the class declaration, we don't know that it's a subclass. So the easy way out is to just put these out of line where we can see the class hierarchy. So we'll do that. And obviously this incurs a little bit of a runtime cost because now you have to make a call and we can't inline it trivially, but let's not worry about those type of things right now. Data.cell. Incomplete typer. Okay. More forward declarations biting me. The JS runtime error. I'm feeling kind of optimistic about this. I mean, I'm sure I messed something up and I didn't think completely correctly somewhere, but I feel like we're in the ballpark of something that should work. So I guess we forgot to put license headers. We can put some license headers while we're here. Clickety clack. 2020, right? I wrote it in the current year. Image data. Yeah, I'm gonna rebuild with those new license headers. And then a couple of things we'll rebuild. Everything that uses libweb, obviously, in libjs, but this is good because then we get to link and see that we're missing something. We're missing create image data in the wrapper. Oh, wait, what? Oh, look, we're missing the class qualification here. That's very silly. It'll work better if those are members. You know, I was saying just the other day that it's so nice to be working on something other than the browser, but today I get to say, oh, it's so nice to be working on the browser again. But I always think it's so nice to be working on something, so it doesn't really matter what it is, as long as it's something interesting. Okay, so where did we put that example? In the id directory, right? So home non id. Well, I guess it was not going to work on the first try. So what did we screw up? Wait, what the heck did I just... Oh, I tried to... Wait, why don't I have history here? Okay, the line editing is not working completely right. So anyway, let's not complain about that. That looks fine. We wanted to look at the other thing. So that was Pixel's example. And, oh, I bet it's this, onload. We're just going to use DOM content loaded. I need to go and fix so that there's such a thing as an onload event eventually. There we go. And okay. Oh, look, you can see the memory usage spike up here. CPU goes up, memory goes up, and everything goes to heck. I guess because we are creating new data every time instead of giving you the same one. So we use so much memory that the kernel crashed. That's nice. Nice things that happen when you are building an operating system. Okay, so, but that's okay. We just need to fix the data getter so that he doesn't always instantiate something new. But wait, why does that happen though? Maybe I'm not thinking right about something here. Create image data is called once. Right? Okay, so we call here create with size. Were we calling this thing multiple times in there? Okay, we're gonna have to look at the code a little bit closer because. Oh, and let's make that fixed permanent here. And listener dom content loaded. Okay, so create image data will happen once on startup image data, and then it will run this code here. So create image and then put image data. And this calls .data. So it's not that we allocate a bunch of these, right? So what does data getter actually do? Gives you the clamped array. Okay, well, I guess we're gonna need some debug logging to figure out what the heck happens. So let's see. Let's log here. Debug. Creating image data with width, height. Yeah, okay, so web and make apps browser and sync and run. So we create one image data and then everything goes to heck. Just absolute heck. So that's not the issue. So is it that we are creating a whole bunch of heap allocations on the JS heap, maybe? Allocate cell. I could see that being an issue, but like, let's just log what's going on here. Then we should probably take some time and work on kernel memory freeing at some point. Because the kernel does not handle the situation well where you just like spam it with allocations, and we do need an auto memory killer mechanism. Because in this case, like a process is clearly misbehaving, it should just be killed. Okay, let's just log what we're doing here. So heap allocate size. I think that would be pretty interesting. Maybe actually, let's not log every allocation, let's log every time that we have to create a new block. Creating block with cell size, and then we'll dump a backtrace here so we can see who took us here. Because at least then we only log every time we allocate a 16 kilobyte block in the garbage collector. Alright, so... Wait, that's not that much either. Okay, oh, wait. Am I doing something really dumb? This has to be something dumb. Because like, this is like barely anything. GC heap is really, really small. I got some 176, 80, 48. So we got like, I don't know, 5 or 6 heap blocks. That's nothing. So page fault. Why are we getting a page fault? Oh, it's been so long since I've been debugging stuff like this that I forget how I used to do it. Okay, well, we're just gonna have to look at what this program is doing, because the fact that it crashes is very annoying, because it sort of prevents us from looking at it. I guess if we could slow it down, then we would be able to see what the heck's going on. So what's something that it's doing? It's doing this thing here in a loop. So we could say every time that you call it request animation frame, we could do a little sleep. So we'll go here and we'll say request animation frame sleep 1. But probably this happens. No, there's something else going on here. Okay, I don't know. Shouldn't make assumptions. I just want to be able to slow the program down. So, okay. It seems like we have maybe slowed him down a little bit now. At least for a moment, and then he died. Request animation frame, it happened once. So in the first iteration, we eventually use up all the memory. Okay, so something in here goes to absolute heck. So is it something here that goes totally wrong? What if we don't set the pixel data? What happens then? We should make this open by default in the browser, by the way. It's kind of annoying to have to open it manually every time. Put image data. Undefined is not a function. Oh, we never installed put image data. So that's good to know. So we'll put image data. So we're hanging in that loop here. In this loop, when we actually assign these things to this thing, then everything goes to heck. That's interesting. So probably when we do that, we're overwriting something that we shouldn't be overwriting. In the uint8 clamped array thing. So let's see. Length is length, allocate length. Okay, well, I'm doing something stupid somewhere, so let's see. put by index at property index, get by index, and let's see what we're actually putting there. That'll be interesting. We never logged that we try to put anything there. Okay. So we never get here. So I guess we are maybe here then. Object put by index. Who calls this? Put, we'll call it. Okay, so I guess we can just log everything that goes on. Put by index. Put. Let's just log everything that goes through put, see what's coming through here. Object put, and then we will log our own class name and the property name, something like that. And this is the object, let's call it put2. And in his case, we have to actually branch a little bit. So property name as number, otherwise as string, and put by index. Oops. Okay, what the actual heck? We are brutalizing a Boolean object for some reason. How on earth does that happen? ImageData.data. What happens if we do this? I just want to see what it says. Or I guess we can console log it. And then we will just not do these. Now I'm curious what the heck this is. It takes quite a while here before it does something. Oh, it's that sleep. Oh, we sleep for 1 second. Oh, and it's printing here. Image data wrapper. True. So this evaluates to true. Now, why does he think that it's a Boolean object? Oh, wait, hold on. Data getter. It's a pointer Oh, dude, this is so deceptive. So it's converted to a Boolean because normally if you do this with a JS value, yeah, then it doesn't. Okay, uint clamped array inherits from JS cell, and JS cell can be used to construct a value. Or not cell, object, I mean. Object can be used to do this, but in this case, we didn't see the class declaration, so we didn't know that uint clamped array was a cell. So in datagetter, what happens here is that this actually takes the Boolean overload of the constructor, this guy. And this is such a stupidly irritating C++ issue that happens every now and then, and always takes me a moment to figure it out. But if we don't use the explicit thingy, then it will complain because it doesn't know how to convert this. Now there is an implicit constructor from object to value, so that's why I like to always use plain return when it comes to objects instead of wrapping them in a value like I had done here by stupid mistake. So if you do this, then it will tell you, hey, I can't convert that to a value. So to fix this, we simply have to include the uint clamped array. So I guess what was happening here was that we were just we were returning a true, like a value representing true, and then we would do toObject on it, and then set a value at obscene index, which would cause it to allocate an increasingly, or a really huge value storage, and that's what swallowed up all of the memory. Oh, I don't want to log all that gunk. I don't want to log all that. Anyway, maybe we can see something here anyway. It's too noisy, but we can see here that it's doing the right thing. So let's get rid of all of those irritating log messages. This will be really nice. Okay. Okay, so I don't know what it's doing now, but it's doing something. Request animation frame fired twice, 3 times. Okay, so we should get rid of that delay, the artificial delay that we inserted here, because that's not helping anything. So it's doing something, and then requesting animation frame again, and again. So it seems like it's starving the GUI for some reason. Maybe we can find out why. Profile, PID 23. Let's see what it's doing. Okay. Oh, I'm up here. So, what on earth are you doing? Randomness. Randomness. Oh, look at that. It's making a syscall for every math.random. That's really aggressive. We probably don't want to do that. It would be better to get a lot of random data every now and then just chunk it up. But for now, we can actually, let's just take the lazy way out for now and not call arc4random, which calls the kernel. We should make one that buffers a little bit of data in user space. Okay, so now we're not hitting up the kernel a billion times. So still need to get a profile though. So what are you doing now? Okay. Okay, so no syscalls at least. That's good. And I think it might just be that this guy is like really aggressively running the JavaScript. You can see he is extremely busy, but he should still wake up every now and then and actually paint to the screen whatever he came up with. So the fact that we're not doing that is kind of suspicious. It makes me think that we're starving the event loop somehow, which we shouldn't be doing. So request animation frame. Yeah, that's okay. Here is the for loop. And variable declaration is very, very heavy. And this expression here that has some assignment in it. Get on property, we're getting the data repeatedly. Yeah, that's very pricey. We could probably sneaky optimize this thing a little bit here by just doing this. Because right now these are like native property lookups that call out to the canvas object, and we can just cache that somewhere. So we'll do that for our data is like that. And then likewise we can move. No, we can't move this out of the loop. Okay, but that's okay. Well, maybe that's enough to achieve something. And then instead of doing a request animation frame, we could do like window set timeout. I always forget the order of the parameters. Set timeout. Callback interval. All right, so main, and the interval will be. Oh wait, it's supposed to have some number. Does request animation frame pass something to the callback? We don't. What's it supposed to pass? Request animation frame. The callback function is passed one single argument, a DOM high-res timestamp. What is that? T-frame, all right, and then it's divisible, so it's a double. Okay, so we should pass it a double, which is the time in milliseconds accurate to 5 microseconds. Well, the best we can do is milliseconds currently in the system because that's the highest resolution timer that we have available in the user space at the moment. But we can definitely pass you that. We just have to make an argument buffer. So this will be whatever, and arguments will be a little thing that we make here. So JS marked value list arguments. I need to include that. Oh, how do we know that? I guess it's a monotonically increasing timestamp, right? It's relative to the previous one. Should it be indicating the point in time when request animation frame starts to execute callback functions? Okay. Mark value list. You know what? I'm just gonna cheap out like crazy here and just say like static double timestamp, fake timestamp. We'll do it this way. Fix me. This is extremely fake. Okay, let's see what actually happens if we do that. Well, it's like it still doesn't have enough time to actually draw anything on the screen. Okay, so maybe we'll do something different, like var t frame 0, and then we'll say t frame plus plus. Yeah, that's okay. And then here we'll do set timeout main 1 second. So don't call me back for a whole second, please. Okay. So now if we do that, then it actually, oh, look at that extreme depth. What happened there? Assertion failed in window resizing. Okay, well, clearly I ticked him off in some way that he didn't appreciate. But it seems like if we just let it time out, if we let it wait a long time in between the frames, then at least we can get it to draw the UI. I wonder why that is. So UI is definitely lagging behind here. It takes forever to draw a frame, but you know, I think we can probably fix this by making the thing a lot smaller. So I should have done this from the beginning. Like, it was kind of crazy going into this with something that like a modern JIT browser can handle. So let's go back to our trusty 40x40. The trusty 40x40, excellent development resolution. Okay, then actually maybe we don't even need to do all that fake jazz anymore. But yeah, clearly he does not appreciate the system that, oh wait, this was in milliseconds. Let's, what are we gonna do? We'll say that it took fake timestamp plus equals 10 milliseconds each time. The system is not very good when it gets completely bogged down, right, by JavaScript, clearly. Reference error, data not known. Okay, so I screwed that up. Oopsie. Okay, look at that. If I move the cursor, we get more request animation frames. That's really not good. It's very tacky. Okay, so it's a little goofish. If I move the cursor more, and more stuff happens. I don't know why the heck that is. I mean, I guess we get more callbacks. It's probably because of the way the display link is implemented in the Windows server side. So are we always sending out the display link? Display link notification. Wait, I'm in the wrong place. I want to look for this, where this one is sent from the Windows server. Not you. Here, notify display link. So this should only fire every time before we're about to update the screen. Fire in the compositor, notify display links in the compose timer, which runs at 60 FPS. But wait a minute. Oh, we turn it off sometimes. Do we turn it off? It's a single shot timer. Oh, wait, hold on. That's why nothing happens. It only happens because the clock up here is making the compositor do something. See, it's every second. It's a clock. So when I do this, I'm driving it as well. Oh, that's stupid. So we were hooking this up to the wrong thing, I guess. We want the, I guess if there is a display link, then we want to just constantly spam compose event. Okay, well that's a separate issue entirely, so we can work on that, but we should commit everything that we've done first. So let's do the clamped array first of all. Lib.js separately, okay. Lib.js, add uint a clamped array. This is a special kind of typed byte array that clamps its values between 0 to it will be used for Canvas, HTML, Canvas, image data objects. Yeah. Okay, it's a very awkward class. Actually, we should comment. I made object put by index and get by index virtual for this. We'll probably need to make string property non-numeric property names, lookups virtual as well, but this solves my current problem well enough. Okay. So then let's ignore the math object thing and just we'll just ignore that. That's the randomness thing making syscalls. And instead, wait, what's going on in this class? I forgot what I changed in that one. Oh, right, the request animation frame getting an argument. We can do that one. Request animation from a. So yeah, this is extremely fake, but we can still add it for now. Libweb hack request animation frame to provide a very fake timestamp. Yes, that's okay. And then we're just adding image data. So clickety, 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 clack. I didn't have to do it that way. Wait. Got. Libweb. Add image data objects and implement canvas crc2d.put image data. It's called 2D context. This an image data is a wrapper around a bitmap, which is a wrapper around a JS uint8 clamped array. Yeah. Can we fit that on one line? Because I like it. Nope. That's pretty cool. So very, very nice. Then I was just thinking, what should we do with that Windows server not sending the display link notifications? Because Windows Server tries to be lazy and doesn't schedule a new compose if there is no drawing work to be done. But if somebody has registered for the 60 FIPS callback, then we gotta send him the 60 FIPS callback, right? So basically, when we enable display link, has display link. So I think what we need to do is just determine, we have to tell the compositor. So compositor, the increment display link count. Decrement display link count, yeah. And then the compositor will keep track of how many display links are active. And then when there are non-zero number of display links, then we will send that notification. Class client connection. Okay, and then we'll just store that in a fancy schmancy size t. Display link count. compositor display link count. Oh, I forgot about the batch. Client connection. Alright, and then we should assert that we actually have display link count. And can we make it not be single shot? Set single shot. Yeah, so we could like the compose timer, we can just start it up. Start it up like normal. Or we can also be kind of, I think it would be okay to do this on a separate timer actually, because this is kind of like, it's not like a real display link, right? Like, but it's not like we are, we're not actually sending out notification whenever the screen is about to update for real. Like what we're actually doing is just doing it at 60 times per second, but there isn't actually any time between program getting notified and the Windows server actually drawing what's in that program, unless we get like preempted in between these two calls and then some program actually renders a new backing store. But even if that happens and it tells the Windows server to switch the backing store to a new bitmap, the Windows server is not going to deal with that until it's done with compose. So this is, it's kind of like we're kind of pretending that it works this way. So I think we can actually put this out and we'll say display link notify timer, and this will be a regular timer that we, wait, is this a core object? Yes it is. So let's see, add a core timer, runs at 60 hertz, and callback is notify display links. Yes, this will work. And let's put this guy together with his friend. Okay, and then here we can just say start. If display link count is 1, then start. If this takes us down to 0, then stop the timer. And actually we want to start the, we don't want to start timer right away. So does it start by itself? I forgot. Timer will start by itself if you call it like this. If you just create a timer like this, it doesn't start by itself. That's kind of ambiguous and weird. Don't really like that API, but whatever. So I think we'll stop this guy by default. And then our main problem now is that you could actually lie to the Windows server. So I think we'll do it this way. If has display link, then return. If not has display link, return. Okay, and then when we destroy a client connection, we'll have to notify the compositor if we had a display link to remove it. Okay, so I think that now we'll have a 60 fps timer in Windows Server that can drive the request animation frame correctly, or at least for our pretend definition of correctly. So well, that's what I thought anyway. This is not working as well as I had hoped. Okay, that's fine. So compositor, let's see how often we're actually sending these. Debug, display link. Okay, we'll just have some number here that we just static int whatever, just something to print. Wait, I don't see anything. Okay, so now we're sending out a ton of these. I guess that's actually more than he can handle. I mean, there's definitely a lot more than he can handle. So what happens if we've notified display links? On the client side, we get notified, and then we want to call all of these guys. That's fine. But when we get this message, we just notify everybody. But I'm thinking, what should we do if we already have notifications like sort of backed up? Like if we're just flooded with these and we can't deal with them. I don't really know what I want to do about that right now. Definitely would like to ignore any future ones, like as long as, like I would want to coalesce these somehow so that like whenever we have a display link notification in the queue, then we would not take in any more ones. So that basically that means that we can't do this synchronously, because right now what happens is in our connection to the Windows server, when the Windows server tells us, yo, display link notification, it's time to do whatever you want in response to that, we just synchronously call notify, invoking all the callbacks. But what if we instead we would do it with a deferral? So we would do something like maybe we can add a member to this guy. So we say like display link notification pending, something like that. And then we'll just do a deferred invoke. So if we have one pending, we'll say return true. Return nothing. And otherwise, we'll do a deferred invoke. Wait, can we do a deferred invoke? I think so. Deferred invoke. Maybe it's just like this, and this is true. Set it to false when we're done. Have to capture this, and then we'll say we have one pending now. Yeah, so this will be called by the event loop. And then we can, as long as we're taking in more of these than we can handle, then they will just get ignored if there's already one pending one, like waiting on the event loop for us to take care of it. That would make sense. So I think this guy is basically going as fast as he can now. And maybe if we actually change back that random thing here, I feel like that was really not very friendly to him, so if we just hack that back. No, it's still depending on me mousing. Wait. I know why that is. This is totally my fault. Because when we paint, we have to say that we painted. Oh, dude, I totally forgot about that. That's why mousing helps. Here, we have to say did draw. And the rect is in graphics rect xy image data width image data height. Oops. So this will invalidate the. Wait, what am I doing wrong here? Can't. Oh, this takes a float rect. Alright, my bad. Float rect then. This will invalidate the canvas in the layout tree so that the browser knows to redraw that part. So, look at that. So, that's pretty cool. Can we make it a little bit, we can make it a little bigger. Maybe like 40 by 40 is not ambitious enough. So it doesn't look quite perfect. It doesn't look like this, right? So something's going wrong with the, oh, now we bit off more than we could chew. Immediately. All right, too ambitious. What about 100 by 100 though? I wonder what's causing it to not look exactly the same. Such a huge difference between 40 by 40 and 100 by 100. Why is it so big? Maybe this speed is okay for now. I shouldn't get too ambitious with the speed apparently. I felt like it was really fast for a moment, and now it's all weird again. Okay, this thing is behaving really weirdly. So was 40 by 40 really such a big deal? Apparently it was. Okay, I don't know why, but 40 by 40 is totally fine. 50 by 50, ooh, starts to have trouble. Anyway, that's just something about 40 by 40. See, if I move this cursor around, it starts to choke. So it's fine as long as I don't do anything else. Anyways, now it's just a performance problem, right? So, but I'm seeing a lot of red that I'm kind of not expecting to see, so I wonder what's up with that. It has like this red dust particles going on. Probably we are screwing up some basic math somehow. Maybe it's the modulo. I don't know. Some stuff to look into. Anyways, definitely gonna save these changes. So compositor changes. We'll just say that we drive him at the 60 hertz. Wait, I didn't mean to add that. window server plus lib GUI drive display links modify display links 60 FPS even if no matter what. The original implementation only sent out applications when there was something being drawn on screen. If nothing was going on, we get too lazy and just not notify display links. This obviously breaks request animation frame. So now we just drive the display links at 60 pips. No matter what. Okay. And then that invalidation fixed finally. Lib web. Wait a minute, I don't want to commit all of this. Git commit lib web. Actually invalidate the canvas element after put image data. Or invalidate. This makes sure we repaint it right away so we can see the changes. All right, so I think we're going to be good here for today because we did a lot of things, made a lot of progress, and although it's not perfect, it is nice. So if you made it this far, then I thank you for watching, for hanging out, and I hope you saw something interesting, and I certainly find this very interesting still. Ah, man, it's just so much fun to work on this stuff. I can't get over how much fun it is. And I hope some of that translates through the videos. I really appreciate all the company. A lot of new company lately, a lot of new supporters and subscribers, so welcome everybody. I hope you like the stuff we get up to around here. And I hope I will see you next time.